on go. So 5x squared minus 6x plus 7. So what's one of the first things I want you to do with this particular curve, this particular function? Whenever I give you a function, what would I expect you to do? Thank you, class. Graph it, Robert. Thank you, class. Very good. Yeah, so graph it. I mean, we know this is a polynomial that opens up. This particular one to do complete the square with is hideous. So, but we don't always have to complete the square. We can cheat on this one. We can just graph this one. So I want to graph this, and I've got 5x squared minus 6x plus 7. And I'm really just trying to figure out kind of where is the parabola. Well, I know it opens up, right? Okay, so there's my parabola. And I get my vertex in my first quadrant, right? So we want to find the secant line. We want to find the secant slope first, right? That's what it's asking us. So let's find that. Let's find the difference quotient. So you're kind of racing me on this. You're not so much just copying what I'm doing. You're going to do your own work and see if we get to the same place, right? So I know my f of x plus h is, I'm going to plug in with empty parens. And I'm going to simplify that. So I might be going fast here, but I'm expecting you to be doing your own work here. But if you do want me to slow down, let me know. When I have a polynomial, this is my process. When I have a quadratic, when I have a radical or I have a rational function, a fraction, I'm going to do the process differently, right? But the second thing I do is I write f of x below this strategically. So my 5x squared is under the 5x squared, my 6x is under the 6x, and the 7 is under the 7. Why? Because I'm going to subtract these, right? And these terms are all going to go away. And notice what is happening. Everything that's left over has a factor of h in it. And if it doesn't, you made a mistake. So I've got my difference now. It is 10hx plus 5h squared minus 6h. And I'm going to make it a difference quotient by dividing by h. And whenever I'm doing polynomials, I'm going to have to factor. And that's when the magic should happen. That extra factor of h in the numerator will cancel. So now it's safe for me to let h go to 0. So I've got my difference quotient of m of the m sub sec, right? The secant slope is 10x plus 5h minus 6. If you've already kind of seen some calculus, you know that f prime of x is when I let h go to 0. So I get just a 10x minus 6. Right, this
plus
is
c.
Yeah, no, that's when you're doing an antiderivative, right? When you're integrating, you need that plus c. So this is Calc 1, this red box. So don't worry about that too much, okay? But the black box is what we're working on now, the slope of our secant line for any x and any h, right? Just a reminder, if you came in late today, we're doing something special on Friday. We're logging in with our phones to class in our testing view, right? So we're going to have a picture of, we're going to have our phone set up off to the side so that I can watch you take your test, not this Friday, but next Friday. So if you need more clarification on that, just stick around at the end of class and I'll go through the details again. All right, we're ready for the next part of this question. We found our difference quotient, right? And by the way,
sorry, Professor.
Yes.
Where did the 5H go?
So from red box is Calc 1. So red box is Calc 1, but let me clarify.
The derivative?
Exactly.
Okay.
Yeah. So f prime of x, called the derivative, is the limit as h goes to 0 of that secant slope. Right? So 5h is in my secant slope, but if h is 0, 5 times 0 is gone. And so then I get, and then this again is calculus. This is calculus, right? This is
got it.
The first,
got it. All right.
Yeah, the first.
Thank you.
Yeah, the first. I would have hoped the first 3 weeks of calculus you would completely understand this, where I went from the black to the red to the green, right here.
Mm-hmm.
Okay, so it wants me to find slopes now. I'm just looking at my problem here. It's asking me to find slopes at a fixed x of 1, right? So it's going to ask me to find slopes. So I'm looking at my curve here. I can't find it because I'm silly. There it is. My curve is here. So at x is 1, right? What do I get? A height of 6? Can someone verify that for me? Yeah, height of 6, right? When x is 1, yeah, I get a height of 6. And I'm interested in secant slopes when h is bigger than, when h is positive. So I'm interested in a secant slope to the right. In fact, I'm interested in a bunch of them. Let me redraw my picture here, okay? Let me redraw my picture one more time so I can get a little more detail. So I'm interested in, and I don't know if it's the vertex, I'm pretending it is. But I'm interested in this secant, right? Let's go green secant. And then I'm interested in the red secant. And then I'm interested in the purple secant. But what I'm really interested in is the black tangent. The tangent line is the one I'm really interested in. That's my instantaneous rate of change. The secant lines, the green, the red, the purple, are going through 2 points. The tangent line's going through 1 point, right? So I'm going to be calculating with a fixed x, 1, 6, right? And I'm going to be calculating my slopes by changing h smaller and smaller and smaller and smaller, right? So x for me is, every time I do it, is going to be 1. And h is going to, I think they start me at 0.5, and then 0.1, and then 0.01. And in calculus, I would have you go one more. I like to say that once I get to gas station money, right, when you're filling up your gas tank, it's got the 3 decimal places. Once I get to gas station money, I should make a prediction pretty damn easily. And I don't like the 0.5 here. So I'm going to change it. I'm going to change it to 0.1. I'm sorry, I'm going to change it just to plain old, well, 1 doesn't make sense here, so I have to keep it, because 1 minus 1 is 0, right? No, I'm sorry, that does work. It's an h value. So I like to keep the consistency here. You can see the pattern in my h's. This is also delta x, right? And I want to calculate that m sub secant here. Now, of course, for me, I got my m sub sec as x. I forget already. Help me. Remind me what we got. We got 2x, didn't we?
10x plus 5h minus 6.
Okay, thank you. Yes. Thank you. So I need my 10x minus 5h minus 6, but I know x is 1 every time. So m sub sec of 1 comma h is 10 minus 5h minus 6, so 4 minus 5h. And I'll just, I mean, this is so easy, I don't really need a calculator for this. So let me skip the calculator. So what do I get? When h is 1, I get a slope of...
Is it 10x minus 5h and not plus 5h?
I don't know. I thought... you tell me. What did I do wrong?
6 plus 5h.
Thank you. Thank you. Good. That makes more sense to me. So when I plug in h is 1, I get a slope of 9. When I plug in h is 0.1, I get a slope of 4.5. When I plug in 0.01, I get what 4.05. And when I plug in 0.001, I get 4.005. So you can really make the prediction now what happens when h goes to 0. Right? So we're talking about the limit of, as h goes to 0, of my secant slope. It's going to 4. Right? Everyone agree with that? So that's the slope of my tangent line. How are we doing here?
Makes sense to me.
Nice. Grace, thank you. I heard a mumble. How we doing? Angel, nice.
Yeah.
Good. Alex, Michelle, nice.
Hi.
Diego, thank you, nice. Let me take attendance real quick. Muhammad, beautiful. Now, here comes the beautiful part. We're going to graph it. Alan, thank you. Eruz, thank you. Thank you for the participation. My other class, they don't even talk to me. I hate them. Oh, I can't, I shouldn't record that. It's too late. I don't hate them. I just don't know them at all. If you don't participate, thank you, Paris. If you don't participate, I'm never going to get to know you. How the hell am I going to write you a letter of recommendation when you're done, when you're transferring, right? So, oh, you remember me?
Shy.
Shy? You think shy?
Yeah.
But what would you do in the class? If we were actually in the class, would you have a bag over your head so no one could even see your eyes, or you know what I mean?
I probably don't talk to you even in class.
Yeah, but I can see reactions, right? I can see them roll their eyes when I tell a joke, or I could see them go when I do a secant slope, right? And they know they're lost. That's all I'm asking for, a little interaction. Nice. Let's take a look at this on Desmos, but we need a couple of things. We need a fixed point, we need a slope, and we need the equation of a line, right? And so I already know my fixed point is
X equals 1.
1 comma 6. Yeah, 1 comma 6. I need the x sub 1, y sub 1, right? And I know my slope of my secant is 4 plus 5h, and I've already put in the x is 1 there, right? Remember, I did that work over here. I put in that x is 1, and I let h stay a variable. So this is my slope, right? And I need the equation of a line, which is y minus y sub 1 equals m times quantity x minus x sub 1. And I'm going to fill all that in before I go to Desmos, before I go to my calculator, before I draw my rough sketch on the test, right? I'm doing all of this work. So what do I get? I get y minus 6 equals 4 plus 5h all times x minus 1. And there's not really much I can do here. It's not really much I can do here, so I'm okay with you leaving this thing like this. So this is the equation of the secant line. Now, on your calculator, you're going to have to move that 6 over, right? Because you're going to go into your y1, right? You're going to go into your function, into what the first function, and then type in the whole thing. Oh, this is going to be a problem. Oh, I know what we're doing. So you would have to do it in this form, but you would have to put in a value for h. So put in 0.5 for h, or put in, oh, and did I make a mistake? No, I didn't. Put in 0.5 for h, or put in 1 for h, or put in 0.1 for h, or put in 0.001 for h. But you're going to see what happens on Desmos. So are we okay with this green? We know what's happening here. Do we realize what's happening? Joe is there. Michelle is there. Angie's always got a thumbs up going, so she's always there. Grace is there. Mohammed, Iruz, nice. Okay, Paris, nice. Diego, yes. Diego?
Yeah.
Nice. Alex. Unisa, thank you. So let's go to Desmos. I don't know why this stupid news feed comes up. I live in DC. I can't stand the politics. It sucks. So I'm going to Desmos. And I'm going to graph my parabola first. Y equals 5x squared minus 6x plus 7, is that right? I want to graph my fixed point. Right, I want to graph my fixed point of 1, 6. Kind of just to double check that I have it right. And there is a way to graph a point. So it wasn't my vertex, of course it wasn't my vertex, right? So I want to have a fixed point on there, and now I want to graph my secant line. Okay, so I got y minus 6 equals my slope of help me again, 4 plus 5h? 4 plus 5h times the quantity of x minus 1. And I want to allow a slider h. And so you can see here, as h gets smaller and smaller, and I'm going to zoom in a little bit here. Right, as h gets smaller and smaller, eventually when h goes to 0, I guess I should put my other point on, right? I should put my other point on. So what is the other point? Let me graph the other point here. It's going to be h. Oh, I better do it down here. Sorry. It's going to be h, comma, the polynomial evaluated at h, which is 5h squared minus 6h plus 7. So you can see, no, you can't, because I screwed up somewhere. Where did I screw up? Oh, it's 1 plus h, right? It's got to be x plus h. 1 plus h. Everywhere there's an h should be a 1 plus h. Remember, because my first x is x, my second x is x plus h, right? So 1 plus h. There we go. And this is now you can see I'll put the secant this way, the opposite way here. You can see my second point is labeled on my secant line, right? So the first point is a little bit tougher to see. There's a pretty clear one. So x is 1, h is, let me make h, there we go, h is 0.4. So you can see that's that second point on my secant line. And of course, what's happening when h goes to 0, I get a slope of 4, right? So what happens when I finally get my slope of 4? I get my tangent line, y equals 4 times x minus 1, quantity x minus 1, oops, y equals 4 times x minus 1, all plus 6, right? And there's my tangent line. So that blue line is the tangent line it's hitting once. The secant line is in green, it's hitting the curve twice, right? And we're really doing calculus here. It's like, it kind of feels like you could handle calculus already if you don't sense it yet. I'm telling you, calculus is easy. The part of calculus that's not easy is you have to have this knowledge of all of these functions, including trig and exponentials and logs, and that's what we're doing the rest of the semester, right? So we're just really trying to build up your knowledge base of all functions and all aspects of functions. But you'll see the calculus will be very easy compared to all the crap we do in this class. How are we doing today?
I got a little confused with the tangent line, the y equals 4 times x minus 1 plus 6.
Yeah, so confused. If I number here, can you tell me which piece of this maybe where you're confused here?
No, just how you got the last part.
Oh yeah. So if you remember, we predicted, if you could see, my secant slopes are going closer and closer to 4. So I can really see that they're going to get to 4. The secant slope's going to get to 4. When does it get to 4? When it's a tangent line, when it hits only once. So doing this on your calculator will be nearly impossible, right? But graphing the tangent line, right? 4 times x minus 1, all plus 6. That's going to be easy for you. That's the tangent line.
Oh, okay.
And then I know I may have screwed up a little bit when I made the mistake, but let me do it like this. If my fixed point was 1, 6, right, that's x, f of x, and my new point is x plus h, right? So that's why, I remember, so I had, for my second point, I had 1 plus h, comma, f of 1 plus h, right? And so it got pretty ugly there pretty quickly. On Desmos, it's pretty nasty, right? But when I'm doing that slider thing on Desmos, I'm showing you the future. Okay, I'm showing you calculus there. No problem, Angie. Okay, so I think we're ready to move on. The next section is very easy, thank God, because we can use an easy section after this particular section. But again, this is the difference quotient thing. So, make sure that you're doing difference quotients with all kinds of different functions, right? Make sure you're practicing difference quotients with different types of functions. So I'll just write a bunch of them. How about an mx plus b, right? How about a quadratic, right? Minus 2x squared minus 5x plus 1, right? How about a simple rational, so like 1 over x? How about a complicated rational, like x over x minus 2? How about a simple radical, like square root of x? Or a complicated radical, like square root of 5 minus 2x. I would, if you can do all of those secants, you can do anything. If you can do all of those difference questions, you can do anything I would possibly give you on the test. Okay? So you should be able to do all of those. And then how are you going to know you're right? A couple of ways. You could pick 2 points on the curve, get the slope the old-fashioned way, the middle school way, get the slope using the secant line. They should match up. You could graph the curve and graph a secant and make sure it's hitting 2 points, right? So like what I just did, where I picked an X and I picked an H, right? And you should be able to do that on your calculator. I would suppose you could do the limit too. You could do the limit of your secant slope, let H go to 0, and then actually graph the tangent line. But I'll wait for you to ask me to do one of those Friday or Monday. Okay? Nice.
Sounds good.
Nice, cool. Thanks, Joe. So let's move on here and look at this very next homework in our list. We're almost done with chapter 2. It's pretty close. I think I'll still need. I've got 3 more homeworks to do, so I definitely won't finish today. I'll finish Friday for sure. And then you have Monday and Wednesday to ask for help, and Friday we take our test. Our homework 10 is, I just call it's still functions, right? In chapter 2, we're just talking about functions, but we're talking about grabbing intervals or grabbing points off of a particular function. There's not much for me to lecture here, so I want to just go in and do some work. This is homework 10. I'll show it in a second. You know, this would be kind of a type of problem that I would expect you have seen in your previous class, which would have been maybe Pre-Cal in high school, or Algebra 2 in high school, or Math 50 on our campus, or at Montgomery College, right? So it's just asking where's my function. Is the function increasing on the interval? I don't like using closed intervals for increasing, decreasing, but the book does. So just you got to give the book what it wants. You'll see when you do increasing and decreasing intervals in Calc 1, you'll use open intervals. So, but it's kind of like, I guess I kind of like thinking about this as I'm walking on the curve from left to right. When am I walking up? Right? When am I walking uphill? Kind of. So is f increasing on from -5 to -2? Yes. Right? So you can see that particular piece. Let me see if I can write on this thing. Can I write on this? Damn it. Why won't it let me write on it? It's so stupid. Can you see my mouse on the curve? Can you see my mouse? Okay.
Yes.
So I'm going from x is -5 to x is -2, right? That's my x interval so imagine the sun is above me and I'm walking up this curve. You can see the shadow on the floor, right? So domain is shadow on the floor. So I'm walking up the hill and you can see my shadow on the ground from -5 to -2. And again, they use closed intervals. I'm not going to ask. This is too easy. Why the hell would I waste a question on a test asking you something like this, right? So, but it's just, that's why I'm saying you should just be able to figure this out. Question 2, is it increasing? Is there a local max at x is 1? Right, that's the question they're asking me. Is there a local max at x is 1? So my interpretation of this, am I standing at the top of a hill when x is 1? That's a local max. Am I standing at the bottom of a valley? That's a local min. And what I mean about local is, you know, the two of us are climbing Kilimanjaro or something. We're both at the top of a peak. Around me, I'm at the very highest point I can be at. Around you, you're at the very highest point, right? And of course, whoever's at the absolute highest point it's called the absolute max. So, but we care about, are you at the top of the hill? Who cares if it's the highest hill? Are you at the top of the hill? That's all we're asking about. So again, nothing to teach here, but you know, got to do a couple of examples, and it's pretty easy stuff. Name all of the x values where there's a local max. So wherever there's a top of a hill, right? I mean, this is. Am I brushing this off too much for you, or is this seem pretty obvious here?
I think it's sketchy how easy it is.
You think I'm trying to trick you?
Yeah.
No, I swear to God, it's really that easy. It's really that easy, but it's something that we want you to be able to do moving forward, right? Be able to look at a graph. This one's interesting. Is this thing even or odd?
Neither.
Neither, right? So if it was even, it would be symmetrical about the y-axis. If it was odd, right, it'd be symmetrical about the origin. And so this one is neither. Take a look at my, so it's asking me on what intervals is this thing increasing. And you can see, it's asking on which intervals is it increasing. I would just give one interval with a union sign. But they're listing multiple intervals. So this book sucks. We're changing it. Even, odd, or neither, no. This one's interesting. What's the domain on this one? Where's that dashed red line at? Can you see where that dashed red line is? It might be a little bit easier here. So the axis is dark black, right? You can see the x-axis and the y-axis labeled. So the range is clearly everything, all reals. I'm sorry, the domain is all reals, but what's the range? What's the lowest the range, the height is at?
6.
Yeah, so open 6 to open infinity, right? It never quite gets to 6. It gets really close. This is an exponential function. And I think that's it for this question. So that homework's done. That homework's easy. Should be a review. So, and if you have trouble with it, it's fine. Ask me, okay? And just give the book what it wants. If it wants closed intervals on increasing and decreasing, that's fine. I don't agree, but I'm not in control. All right, here we go. Homework 10, piecewise function. Homework 11, piecewise functions. This one most students usually hate. But this is really important for us.
Oh, not piecewise.
Yes.
No, we can skip that.
Nope. Homework 11. This is from 2.4, and we're talking about piecewise functions. So the most famous piecewise function that you know is absolute value of x, right? So if f of x is absolute value of x, we know that splits it into two pieces. It turns it into y equals x if x is greater than or equal to 0, and y equals the opposite of x if x is less than 0. And so this is the idea. These are my two pieces, right? So this is piece 1, function 1, domain 1, function 2, domain 2. And so I could have a 2-piece function, a 3-piece function, etc., etc., etc. And what do we have to be able to do? We have to be able to graph everything, of course. So here's y1, and here is y2. So, and all of the graphing that they're going to ask you to do is pretty simple, but we're going to be doing a lot with this, with functions in Calc 1. So we're interested in as I'm walking left on that green piece, right? As I'm walking downhill on this green piece, right? Or I'm walking downhill on this red piece. Will I eventually meet at the same point or not? And so the answer here is yes, right? So these are limits that we're talking about. So it's the same idea. As I let h go to 0, will my secant line become a tangent line, right? That kind of thing. So we're talking about the two pieces in this case, right? In the secant line, we're talking about the 2 points, right? So here, 2 pieces, am I going to the same place? For the secant line, are my 2 points going to lead up to a single point, and then am I going to have a line there, right? So this is huge for us in calculus. So we want to make sure we can do several things here. What do I have to be able to do? I have to be able to, given a piecewise function, graph it. Given a piecewise function, find values. Given a graph, find the piecewise function, etc., etc., right? So all those different types of ideas, but every piece along the way is very simple. And I will show you how to graph a piecewise on Desmos, and then you'll do just a quick Google search, how do you graph a piecewise on TI-83, 84, right? So you should make sure you do that on your calculator as well. All right, let's look at a couple problems here. There's just not much to do in terms of lesson. Again, this is something you would have been doing in Algebra 2 and or Math 50. So here's my very first function, and it's just asking me a bunch of things. Find f of -4, find f of 0, find f of 2. And so we're really just talking about here domain and range. And so you can see my function piece. So I just took a quick picture of this, and I'm going to write it on the next page. But once again, my function in piecewise function. So this is homework 11, number 1. And my piecewise function has 3 pieces. My first piece is an x squared curve. Do we know what that looks like? Hell yeah. When should I use it? Only when x is negative. Only when I'm talking about negative numbers. So I like graphing this right away. I already know what, right? You can see my x squared curve. I only want that solid piece of it, right? When x is 0, I should hit a height of 3. When x is 0, I should hit a height of 3. 1, 2, 3. So I got a singleton point there. And when x is positive, I want the curve y equals 2x plus 4, right? So at 0, I hit a 4. At 1, I hit a 6. So you can see I'm kind of answering a couple of our types of problems here. I'm answering, can you graph the piecewise function? If I give you a piecewise function, can you graph it? The answer should be hell yes. Okay, but what did they ask me? They asked me to find f of -4, right? All right, so the question is, which machine do I use? Which piece do I use? The first piece, the second piece, or the third piece?
First piece.
First piece, right? So I'm looking at domain inside, and I'm matching up with my domain piece. So of course I get -4 quantity squared, which is 16. It's that simple, right? What's our next one ask? What's f of 0? Well, which piece do I use? Well, it's the domain for the second piece, right? That second machine. And of course I get just a height of 3. And when last one asked me what find f of 2, I just have to plug in 2 to that last piece. That's 2 times 2 plus 4. That's 8. And so it's really not difficult. I think the more difficult piece would be graphing the function, right? But do you know how to graph an x squared curve? Hell yeah. Do you know how to graph a point? Yeah. Do you know how to graph a line? Yeah, all you need is 2 points, right? So I picked 2 points. So when I did the graph for this one, right, x and 2x plus 4, I picked a 0, but notice it's hollow, and I picked a 1, and I got a 4 and a 6, and so then I just graphed those 2 points, right? I graphed the 0, 4 as a hollow, right? And I graphed the 1, 6 as a solid, and then connected them to the right. It's nice to do these on Desmos, these piecewise functions on Desmos. It sucks on our calculators because it's a friggin' dinosaur. But y equals x squared is my first piece. And all I do is I say curly bracket. What was it? X is less than 0? X is less than 0. And then I get that half of my quadratic there, right? I had the other point was 0, 3, right? 0, 3 in a point notation. And then I had the line y equals 2x plus 4. Is that right? 2x plus 4? I forget. 2x plus 4, curly bracket for x greater than 0. And and you can see it gives me that grayed out dot. The grayed out dot is the empty circle, is the hollow point. There really should be a hollow point at 0, 0, 2, but I don't know why it's not giving me that. I think maybe if I just focus on that curve, I get the hollow point. If I focus on that curve, no, it's still not giving me the hollow point. Maybe there's a way to get that.
Maybe click the point on the left of it.
Yeah. Oh, yeah, if I'm touching that curve, it's giving me one, but the other one it's not. I don't know. Not too worried about it. So piecewise functions, it's not too bad. You just got to be patient, right? Be patient. You'll never be a doctor if you don't have patience, right? Kind of thing.
That was better.
As my father used to tell me that. You'll never
Marginally.
This one's probably a little bit more difficult to graph, but not really, right? So but find the values and graph the function and all of that. Find the domain of this function, locate your intercepts, graph the function, find the range. Is f continuous on its domain? There's some calculus. Is there a hole in the graph or not, right? Is it a nice, is it a roller coaster that won't kill somebody kind of thing? Same thing here. Let's do this one. So this is homework 11, number 4. So I've got a 3-piece function. I've got an x plus 3. I've got an 8. And I've got a negative x plus 2. Right? So those are my 3 pieces with domains of the first machine is going to work from -2 inclusive to +1. The second point is a singleton point. And then the last one is when x is greater than 1. So I'd like to graph all of these. They're pretty damn easy. We should be able to do them quickly, but if I go too quick, please let me know, okay? So I'm going to label them y1, y2, y3, right? Kind of. And I'm looking at my domains and everything else here. This is just kind of my scrap work. But I want to, obviously I can graph 1, 8, 2, 4, 6, 8. Who do we appreciate? For the other two curves, I just need 2 points. And it's easiest for me to use the points that are in the domain or almost in the domain. So for y1, I'm gonna use -2 and 1. And so when I plug in to that first machine, when I plug in the -2, I get a 1, and when I plug in 1, I get a 4. So at 1, I get a 4, and it's empty, and at -2, I get a 1, and it's solid. So there's my y1 piece, there's my y2, and now I just have to graph y3. Are you with me here? So it's go ahead.
I just want to know that the x1 and 4 is empty because x is less than 1, right? Or what?
One more time, Diego. I was having a little hard time hearing you. Say that again.
And x, 4
Yes.
is empty. Why?
Here.
Yeah, on the graph.
Yeah.
Getting, like,
Oh yeah. Why is it empty? Because there's no equal sign. Why is it solid?
Okay.
Because there is an equal sign.
I just wanted to make sure.
Yep. So for y3, that should be y3, right? For y3, again, I just need 2 points. I'm going to pick the first point as 1, and the second point I'll pick as 2, right? So at 1, I get 1, and at 2, I get 0. So at 1, I get 1, and that should be empty. And at 2, I get 0. And that goes forever, right? That piece is gone forever. How we doing?
Makes sense to me.
Not too bad, right? Not too bad. It's just, I don't know. It's annoying. That's all. It's just annoying. All right. So what are the questions it's asking me now? Now that I have a nice graph of it, it is asking me find the domain. So it's pretty clear that the shadow on the floor is everything from -2 to infinity, right? And of course, since -2 is included, I use a solid, a square bracket. And since I can never get to infinity, I'm using an open parenthesis. Locate any intercepts. So it looks like I have a clear x-intercept, right, that came from me graphing at 2, 0. And I get a y-intercept of what, 0, 3? Does everyone agree with that? Just by plugging in values real quickly. Graph the function is part C, done. Find the range. The range is a little bit strange here because you do see I have a high point of 8, right? And I have a low point of -infinity. If you're just looking at the graph, how far down is the graph going? So I want to say my range of f is -infinity up to 2 union with the singleton 8. So -infinity, if you can look on my graph here, right? I'm at -infinity. I'm going up, I'm going up, I'm going up. I almost get to 1, but then I jump over here and I do hit a height of 1. And then I'm going up and I'm up and up. Oh, that's a 4. Sorry. That's a 4, not a 2. But you see that high point here is a 4, but open. So I can't actually get there. But then I can jump to that singleton height of 8, right? Maybe I get a helicopter ride up there or something. Is this thing continuous?
No.
No. It's got holes in it, jumps in it, right? That's what I'm looking for. Continuity. And you'll talk about several things in calculus. Do I have a limit on this curve? This one's got no limit, so it doesn't match up right and left. This one has a limit, but it's not continuous. So it has a limit, but not continuous. There's a hole in it. It really means that it's that simple. And then this one is continuous, but not differentiable. Not differentiable. It's not a smooth ride on a roller coaster. There's going to be that really awkward moment there when you're switching directions. And it's all about slope. Differentiable means derivative. Derivative means slope. So I'm looking at the slope from the left is positive. The slope from the right is negative. And so when those slopes don't match up, when the curve doesn't match up, no limit, right? When there's holes in the curve, but it does match up, not continuous. When the curve matches up and has a limit and is continuous, but it has different slopes, it's not differentiable. So we like to say things that are differentiable, like x squared, is a real smooth ride. Real smooth ride. It exists at every point. The slopes move together really nicely, kind of thing. And of course, all of this is related to machinery, travel. When we're creating things, we have to make sure that if I'm jumping from first gear to second gear, it should be differentiable. It should be smooth, right? Nice. I think that's it. I feel like I'm going really fast today, but I think the stuff is easy. So, but you're going to let me know. I don't think you're all asking me enough questions, honestly. But we'll find out, right? I guess this one's okay to do. We'll do one more here. So they give me a graph, and they want me to create the piecewise function, right? They're giving me this graph, and they want me to create the piecewise function here. So I'm just going to take a quick photo of it. Oops. Just so I don't have to keep looking back at it. So given a graph, create the piecewise function. I don't think this is difficult. I mean, maybe I'm just in a bad mood today, and I don't care about you right now. No, it's not true. But I need you to communicate. That's all. So it looks like I have on my second curve I have 0, 0, and 2, 2. So that's y sub 2, right? 0, 0, and 2, 2. The old ballerina point. And on the first curve, it looks like I have 3, 0, negative 1, 2. Yeah, negative 1 and 2, and 0, 3, but 0, 3 is empty. So negative 3, 0, negative 1, 2, and 0, 3. And that's my y1, right? And I want to just create the piecewise function. So it's a two-piece function, right? So I have to think about, I need y1 here, I need y2 here, I need the domain of y1 here. Oops. And the domain of y2 here, right? And that's my plan. So figure out what the functions are, figure out what the domains are. So domain for the first piece is obviously negative 3 included all the way up to 0 not included. I'm just looking at the ground there. I'm looking at the shadow on the floor there, right? So negative 3 I can get to. 0 I cannot get to. Notice that the point on the curve does not exist at x is 0. And so that's why I leave that domain piece out. And for my second function, it looks like I'm going just x is greater than or equal to 0. Right? As I'm walking on this curve, I can see my shadow on the floor as I'm moving. It's everywhere to the right of 0, including 0. How is that for everybody? This stuff is boring as hell today.
Right.
So, Diego, yes, you okay?
Yeah.
Nice. So, so now to get the curves, all I need is the slope and the y-intercept, and on both of them, it's done, right? So the first curve has a slope of 1 and an intercept of 3. So there it is, x plus 3. And the second curve has a slope of 1 and an intercept of 0. So x is 0. Done. I mean, it's insulting. I'm sorry. It's so easy. So I'm just looking for slopes and intercepts. And in this particular case, it's very easy to see both. Nice. Well, I'll tell you what. Even though I could move on, let me just let you out early today because I did enough. Everything's easy. You've got work to do.
Awesome.
I already took attendance, so everything's fine there. So I will see you Friday. Remember, let me remind everyone, Friday you're coming in on your phone or on a camera that's going to watch you take your test, and you should have a kind of a view of, I should be able to see where you're writing. I should be able to see some of you. Should be able to see your monitor, your keyboard, your mouse, the paper you're going to be writing on, right? So I've got room to write right here. And then I've got a formula sheet maybe as well. Maybe this screen is my formula sheet, or this screen is where I'm writing, and I've got a formula sheet there. And I should be able to see everything you do. I don't mind if you listen to music when you take your test. You know, you can have headphones in. My problem, no, test is not this Friday, it's next Friday. Because Friday I'm going to finish chapter 2. So I would never, when we test, I don't do any lecture. Okay? So when we test, I don't do any lecture. We take the test and we're done. And then we take the weekend off, right? Hopefully. And so, I forget what I was saying. I don't think I was saying anything else. So that class Friday, come in with your phone, right?
Are we going to be able to film the entire class?
No, and then I'll say, okay, you're approved, and then you can switch back to whatever you want to do. When you take the test, yes, the phone will be watching you the whole time. Yeah.
All right.
Nice.
Got it.
Nice.
Thank you.
See you Friday.
Professor.
See you Friday. Yes.
See you Friday.
Yes.
Hey, Professor.
Yes.
Bye, Professor.
See you later. Sean, you're going to stick around?
I'll be back.
Yeah.
Nice.
Professor,
Okay. Grace, what's up? You okay? Yep.
I'm good. I was just saying thank you.
Thank
and
you.
Have a nice
Thank
day.
you, Grace. Thank you. So, Sean, let me just make sure no one else has questions before we look at something. Malcolm, are you saying you got confused a lot today? Was it the secant line or what?
Well, in general, I don't know how to manage. Maybe I was not practicing the math in the last some years. So I don't know, I'm confused. Maybe, can you just advise me how to handle easily, especially today's session was...
Well, jump in there.
I was not able to-
This is what I'll say to you. Jump in there and start doing problems, and then if you need help, come to office hours. Come to office hours. I'll help you, one-on-one.
No. Okay.
And that's what they're for. Absolute office hours are for.
Okay. Let me go through it today.
Exactly.
And,
Exactly.
probably tomorrow I will be driving to another state. So on Monday, if you give me time, I mean on Tuesday or
Of course. Of course.
one day before the test.
Absolutely.
Okay. Thank you.
Yes, you'll be fine. You'll be fine.
Mm.
Caleb, Ethan, Brandon, any of y'all need me? Did you fall asleep? All right, Sean. So welcome to the class. Let me show you a couple of things. I think I'm still. Let me stop my recording, by the way. I don't know if I did yet. No.